Okay, so on your calculator, what we're going to find here when we solve these trig equations is really a trig equation would most of the time would have an infinite amount of solutions. So, we only find the solutions that sort of fall in a certain range, and that range here is in between 0 and 2 pi. Okay, so that limits them a little bit, so we're not listing answers for every. Now, since we're saying it this way, notice I'm not saying 0 to 360 degrees. And by the way, that's our basic unit circle, isn't it, from 0 to 2 pi. Okay, so we're doing ones that only lie on a circle that would make one revolution. Okay, one revolution of 2 pi. Now, since I'm not saying from 0 to 360 degrees, then we're referring to every solution as in radians. So you need to have your calculator in radians. Right? So do y'all know how to change them here to radians? I'll walk you through it if you don't. You go to mode, and then that third line there, you got to make sure here that says radians. Okay. Right. Press enter, and it'll lock it on radians. Now, one thing that's going to bring you in this next test, your calculator will stay in radians. Okay, but on the final exam, you'll be expected to sometime during that exam to switch it, because most of the things that we've done have been in degrees. We keep the calculator in degrees. So this is a case where we're now going to put it in radians. So you'll have to have the frame of mind that, hey, sometime during that final test, I'm going to have to switch back and forth. Now, let's look at an example of a trig equation. And this is one that we would solve with a calculator. Okay, so let's start with this one. So we have cosine of theta equals 3/4. Right now, so here's the thing. What's going to happen? The calculator is going to give me a really, really nice, easy answer to find. But the thing is we're actually going to have two solutions, and so one of those solutions is going to be kind of difficult to get. All right, you're going to have to do a lot of work with it. Now, let's see if you guys can help me on the calculator part. This is the easy part. So, what do we actually punch in the calculator to get the answer to this? How do we undo the cosine on both sides? The inverse. All right, so the inverse is the same difference as dividing by cosine. So we take the inverse cosine on both sides. So what amounts to happen here is just we would do inverse cosine of 3/4. All right, punch it in with me. Okay, and you got to pretty much punch in everything with me today to kind of see this. So do an inverse cosine of 3/4. Okay, so that's about 0.72. So we get theta is about 0.72. So we're going to go to two decimal places. Now, the thing is, that's only one of the solutions that would lie in between 0 and 2 pi. And so there's another solution. All right. Now, here's the way that I want you to look at this. You have to draw a picture a lot of times to get the second solution. So we're going to draw a picture of our unit circle. But since this is in a decimal form, what we need to look at is our angles in a decimal form. Okay, now this one would be 0. And now, what right here we'd say pi, right? But how would we write that pi in the decimal form? That would be degrees, 3.14, right? Okay, now this would be half of that. So if you didn't know it, you could say pi over 2 on your calculator. Okay, but that's going to give you about 1.57. Now, this one is 3 pi over 2, and I can't remember this one too well. Punch it in for me. I think it's, let me think, 4.71. All right, is that it? And now, what would 2 pi be? Yeah, 6.28. It's 3.14 times 2. Okay. Now, so that's the way we're going to look at sort of the unit circle is in terms of decimals. Now, where would 0.72 lie as far as its angle? right? So in the first quadrant then, right? It's about halfway in between, pretty close, all right? So we don't have to draw it exact, so we're going to draw that answer out. So this angle here is 0.72. And see, this is kind of hard to get past because normally when we do this, when we do angles, we think in terms of degrees, don't we? You know, we really don't think of angles. So it's kind of hard to visualize. Now, let's look at this. That's one of my solutions. There's another solution out here somewhere. Now, here's what I want you to think about. We're saying the cosine of theta is 3/4, which is positive, right? Now, where is cosine positive? In the first and, yeah, the fourth, right? So here's the thing. Since cosine is positive in the first and the fourth, we're going to have another answer in the fourth quadrant, and that's what we got to figure out. Okay, now to figure out this angle in the fourth quadrant, I'm going to do this. Basically, it's going to be the reflection of this angle. Okay, so it would reflect down this way. Now, the way I'm going to have to figure that angle out is to use a reference angle. Okay, now since this angle is in the first quadrant, and I always do my reference angles in red here when I do this. What's this reference angle here since this one's in the first quadrant? Just be what? 0.72. It's the same, right? Remember, if it's in the first quadrant, the reference angle is the same. Okay, so now what we're going to do is look at the same angle down here that has the same reference angle, but a different angle in standard position. All right, so the reference angle down here is still going to be 0.72. All right, it's just the 0.72 that's in the fourth quadrant instead of the first. Now, let's see if you guys can figure out here, how would I find this angle in standard position though? So remember, standard position goes from 0 all the way around to here. All right, now think about it. What's completely all the way around? Or 6.28, 2 pi, right? So how would I just go from here to here if I know that that part is 0.72? Subtract it. All right, so really it'd be what, 6.28 minus 0.72. Now the thing is, that would not be exact. That would be an estimate. So what is this exactly? 2 pi, right? So it would be 2 pi now minus this, but with all the decimal places. So how do we get all the decimal places on our calculator? The answer button, okay? So we'd punch in here, all right, 2 pi minus answer. Okay, so this angle in standard position now is about 5.56. Okay, and that's my other answer. So we got theta is also about 5.56. Okay, and usually what happens is, nobody's going to miss that first answer, right? I mean, just throw it in the calculator. That's it. But you've got to figure out this other angle. Now let's go back through how we found this answer. Okay, so we got 0.72, which was in the first quadrant. Now, how did I know I was supposed to draw this angle down here and maybe not in over here? All right, cosine is positive in the first and fourth. All right, and so when I drew this angle, it would have the same reference angle. And you remember the reference angle is always formed with the x-axis. So it's the same reference angle, but in standard position, it goes all the way around here. So that had to be 5.56. Okay, so what usually people have trouble with is coming up with a second answer by having to draw it, because it's really